Good evening. Good evening, everyone. Welcome to the preparation strategy of signals and system related to GATE and ESE exam. Okay. In what way we have to prepare the different topics of signals related to different chapters? How the examiner is going to concentrate? Those things we are going to observe in today's discussion. So this is the normal weightage of different branches, ECE, electrical instrumentation related to GATE paper. ECE, electrical instrumentation, for the past 5 to 6 years data, it is available. See what happened. Normal weightage of this particular subject is 9 to 11 marks in GATE, general. But if you observe here, 2023, this year what happened? See the weightage. Almost 12 to 14 marks were given. Of course, different branches. 12 to 14 marks. As they have introduced discrete Fourier series, a new topic, especially for electrical students over the last 2 to 3 years. DFT, DFS, they are one and same, with a minor change. Small change will be there. So they have concentrated some good questions even related to discrete Fourier series chapter. So almost 12 to 14 marks we got related to GATE exam. With respect to engineering services exam, with respect to ESE, see the weightage. Of course, some part of for electronics communication, electronic telecommunication engineering, we will say in ESE, some part of signals and system is added in advanced electronics, where we have to deal with the topics like filters, digital filters, IAR filter, FIR filter, and some application part of signal processing also. But for electrical, it is a separate paper, systems and signal processing. See the number of objective questions. Almost the range is from 10 to 14. Of course, luckily you are getting simple questions with respect to ESE. But filters, even they have introduced this year for electrical students in the engineering services paper. Some questions, it is there in the syllabus from so many years, but this year they have given some specific questions related to that. So GATE weightage is average 9 to 11 marks, but this year it happened for 12 to 14. With respect to objective paper, ECE can expect 7 to 8 questions. Electrical, 10 to 14 is the average. So I want to give a motivational quote for you. Please go through it. Learning is the only thing the mind never exhausts, never fears, and never regrets. According to me, learning is earning. If you are learning something, you are earning something. So I loved the quote, so just I want to discuss with you. Okay? Now let us see the details, which topics we have to give more concentration. With respect to the basics of signals and system, introduction, we have to concentrate on different properties of impulse. One is the product property. To tell you, any signal multiplied by shifted impulse equals to, try to check the signal at the respect to shift x of t naught into del of t minus t naught. Similarly, shifting or sampling property, convolution property, I'll give the idea when we see some examples related to that. There will be a definite model in competitive exams related to the properties of impulse. Like scaling property of impulse will be there. If you want to scale the impulse by alpha units, its area will be scaled by 1 by mod alpha units. We have standard functions like step function, ramp signal, all these are there. But maximum concentration will be given on properties of impulse. That is one topic which you have to concentrate related to the exams. Next one, energy and power. How to find the energy or power of a signal? in the time domain as well as frequency domain. Frequency domain means it comes under Parseval's theorem. In frequency domain, it comes under Parseval's theorem, that is considered in Fourier domain. Maybe Fourier series, Fourier transform, like that. But energy and power signals is a regular model in GATE paper. Regular model. They may frame a question related to time domain or it may be frequency domain. Periodic signals, maximum times they will ask only find the fundamental period if you feel it is periodic. But in frequency domain, we have to deal that as what? One is the continuous form of Fourier series. The other one is discrete form of Fourier series, where we are taking spectrum concept. So periodic signals, how to find the fundamental period or fundamental frequency, we are following a approach. After that, how to deal in frequency domain means continuous Fourier series and discrete Fourier series. Then the other topic is systems and classification. Generally, we are dealing with 6 systems: linearity, time invariance and variance, causal, non-causal, static, dynamic, stable and unstable. All these systems, there will be a definite question, especially for electrical students. Almost every year there will be a GATE question on this particular topic, systems classification. What the examiner will ask generally is, he will give the relation between input and output, yn, xn, yt, xt. He may expect any 3 properties. There are generally 6 forms of systems: linearity, time invariance, causality, static or dynamism, stability, and the invertibility. 2 to 3 system properties regularly we are getting in the exam, regularly. ESE also you can expect 1 or 2 questions from this particular topic. In engineering services also you can expect 1 or 2 questions. The second topic is linear time invariant system, where we are dealing with the word convolution, LTA system. There you should remember some combinations, standard combinations. To say some examples, ut convolved ut, step function convolved by itself is ramp function. 2 unequal length signals, 2 unequal length rectangular pulses, if they are convolved, they are of unequal length means we are going to get trapezium shape. If they are of equal length, if both rectangles are of equal length, it will be a triangle, like that. Some standard combinations you have to learn. Okay? Mainly their favorite model, either GATE examiner or ESE examiner, their favorite model is convolution of 2 finite length sequences, where I am going to explain one example for you just for understanding purpose. What examiner will concentrate, that basic thought I am giving now. What examiner is going to concentrate. Then the properties of convolution. There are some properties like time scaling property for convolution, area property, shifting property. Those properties, total 4 to 5 combinations are there. All are touched already in the exam. They used to ask the property. But this year for ECE what happened? Property application they have given a model. Area property application they have given a particular example. Like I mentioned with you just now, finite length signals, convolution, deconvolution. What is deconvolution? Finding the input signal or system. You know the output as well as you know the input. Find the system. How to find that black box Hn? That is called as deconvolution. Or we know output and system. How to find the input? Then also we need deconvolution. Then the properties of LTA system. See, in the introduction we are learning the relation between input and output, yt, xt, yn, xn. But once the word LTA is used, we are dealing with the word impulse response, h of t or h of n. So with respect to impulse response, whether it is causal function, whether it is stable function, those models are also compulsory, regular models. Okay? So let me show you the next point. Fourier series, where we are learning trigonometric form, exponential form of Fourier series, 2 forms of Fourier series. Their maximum concentration regular model is on this effect of symmetry on Fourier coefficients. Generally, what symmetries we are learning? Even symmetry, odd symmetry, half wave or rotational symmetry. So they are going to provide a periodic signal graph for us. They may ask out of A0, AN, BN. Those are called as the trigonometric Fourier series coefficient, which are possible. It is a regular model in competitive exams. Regular model. RMS value and power of the periodic signals. In GATE syllabus of electrical, this is exclusively mentioned. Square root of power, RMS value. Root means square value. That is also a regular model. With respect to properties of Fourier series, they are going to concentrate few properties. There are so many properties. There are so many properties in each topic. Maximum concentration will be given in time shifting, scaling property and Parseval's theorem, where you are in a position to know the power of a periodic function in frequency domain by using Fourier series coefficient. If you want to get the power up to certain harmonic number, we are in need of using Parseval's theorem. It doesn't mean the other properties are not concentrated. We have time differentiation property, frequency shifting, convolution property. They are all there. Maximum concentration in this chapter is given for these three. Okay. Next, Fourier transform. Next, we are dealing with Fourier transform. To be free and frank, this is the main topic where 50% of your GATE or ESE models will be asked, because it is the first transform we are learning. 50%. You see the old papers, definitely you will get an idea. 50%. Minimum 2 mark questions will be there, 1 mark question will be there. Pakka. Of course, with applications like sampling, all that. So there are so many standard signals for which we have to know Fourier transform. First, its basic definition, because based on the definition also, some models will be framed for us based on the definition of forward transform, inverse transform. Rectangular pulse, if we take a symmetrical rectangular pulse, we are taking its spectrum as either SAF function or sinc function. Gaussian, bell-shaped curve, Gaussian spectrum is again Gaussian. SAF function becomes rectangular spectrum. Some standard signals which we are using regularly, two-sided exponential, all these standard relations you have to learn. Okay? Then the properties of Fourier transform with the different examples. You have to deal with properties of Fourier transform, differentiation in both forms, shifting in both forms, convolution property, Parseval's theorem, all those you have to concentrate. Okay? Sampling theorem is a habituated model with respect to Fourier transform application. So on properties, you will get 1 question. On standard signals, you will get 1 question. What happened this year for ECE? Gaussian spectrum is directly asked, which is formula based. He has given a Gaussian function, he wants the spectrum, formula based. With respect to properties, some models will be asked. With respect to properties, sampling theorem, like what are the frequencies at the output of sampler? What is Nyquist rate? Minimum sampling rate required is called as Nyquist rate, which is 2 times the highest signal frequency. So those type of models will be touched. Autocorrelation and cross correlation, comparison of the signals is generally called as correlation, comparison of the signals. So autocorrelation, cross correlation related to energy spectral density and power spectral density in frequency domain. This is also one application part, especially for ECE students. It is linked to communication subject also. When we are dealing with noise, multiple times we are using the word PSD, power spectral density. Then we are dealing with Hilbert transform, that is 90 degrees phase shifter, that has given the idea of pre-envelope and complex envelope, Hilbert transform. Of course, I have not seen that many models on this Hilbert transform, but they will touch this also. Actually, here we are dealing a topic, distortionless transmission. To avoid distortion, what is the general condition in frequency domain? magnitude spectrum constant, phase is linear. Standard theoretical question. Distortionless transmission. Certain times they may deal with phase and group delay also. You can say it is a miscellaneous topic. Very old papers we used to get. Recent times, one or two times, recent years, one or two times they have given some models related to phase and group delay. Distortionless transmission is also an important topic. So if you see in a proper manner, observe in a proper manner, if some 6 to 7 questions were given from signal subject, at least 3 to 4 questions are from this particular chapter. See the importance of Fourier transform. Be thorough with Fourier transform. The fellow who wants to be good in signal subject, he must be good with Fourier transform. All other are automatically easy. So these are some of the things you have to concentrate. Okay. So there will be a definite question every year on sampling theorem, property application 1 question, Fourier transform of some standard signals is 1 model, application part for ECE, gate for electrical they may not touch this topic, but in engineering services it is a most important topic, electrical engineers. For ECE it is Paka in gate exam as well as ESE. Electrical engineers correlation till now a single question was not asked in gate paper. But in ESE, even in discrete domain also they have framed few models. Okay? That is about Fourier transform. Just I am giving an idea which topics to be more concentrated. Okay, let me show you the next one. Laplace. Laplace mainly we have to deal with region of convergence, ROC. Signals question in Laplace or jet transform means mainly they will deal with region of convergence. When the signal is right side, what is happening? Left sided, two sided, what is the intersection ROC? Where we are dealing with the word sigma or real value of S. S is a complex variable. Okay? An ROC based question is regular model in Laplace. Then the initial value, final value theorem, what are the constraints? Final value theorem, you are aware, when the poles are lying on the imaginary axis or pole in the right half of the S-plane, it may fail. Time domain, transform domain will not give us the same answer. So you must be careful. So whatever that mistake we are ready to do in hurry in the exam, they will frame a question related to that. So you must be careful. Under certain condition only the final value theorem or initial value theorems are valid. When the poles are lying on the imaginary axis, pole in the right half of the S-plane, automatically our theorem fails. So we should observe that type of points. Causality, stability in S-plane, Laplace domain. Normally we will say causality means impulse response must be 0 for negative time. But here with respect to ROC we are dealing. ROC is right of the rightmost pole. In Laplace domain, we will say ROC is right of the rightmost pole. Stability means ROC must include imaginary axis. So they will give some transfer function. They will give some transfer function for us. They will frame the question. If I want to make the causal impulse response, get me the result. Based on ROC, we can decide the answer. Or if I want stable impulse response, then you get me the answer. Or if the word Fourier transform is defined, Laplace domain expression is given, the word Fourier transform is defined, is used. What is the indirect meaning? ROC must include j omega axis. So they will look like simple points only, but you should grasp them in a proper manner. All those points you have to grasp in a proper manner. This is also regular model. Steady state response due to harmonic inputs. When you are applying cos omega naught t, sin omega naught t or switched cosine and sine waves, cos omega naught t ut, sin omega naught t ut, due to harmonic inputs, how we are going to get the output? Generally, output is a combination of two quantities. One is the transient response, the other one steady state response. Steady state response is a regular model in the exam, regular model. It may be asked with respect to continuous domain or discrete domain. That is regular model. Okay. Then we are going to observe the models related to DTFT jet transform, discrete time Fourier transform and jet transform, in which the first and most important point to be observed is relation between analog and digital frequency. Analog frequency is limited for, what is the range of analog frequency? Minus infinity to plus infinity. But our digital frequency, because the spectrum periodically repeats, minus pi to plus pi. You try to draw the spectrum for a specific range minus pi to pi, after that it periodically repeats. Because I hope you are aware with this statement. Periodic or sampling in one domain will cause discrete nature in the other domain. Continuous in one domain becomes non-periodic or aperiodic in other domain, because of which we are learning all frequency domain concepts. Once you take periodic signal, it will give us discrete spectrum, that is Fourier series. But if you take a discrete signal, it will provide periodic spectrum. That is the concept of DTFT or DFT. Continuous in one domain becomes non-periodic or aperiodic in other. Even this funny point was touched in the latest gate paper for ECE. Okay, match the following type. Based on only that statement, simple statement. Okay, then filters. They may provide you impulse response. Or transfer function like h of s, analog domain, hz, here h of t or h of n. Or they may provide differential or difference equation. Our job is whether the given expression corresponds to a low pass filter, high pass filter, band pass, band stop, all forms of filters. So in analog domain, we are trying at starting frequency and ending frequency like omega tends to 0, omega tends to infinity to know the nature of the filter. Similarly, in discrete domain, what frequencies we are dealing? Omega tends to 0, omega tends to pi, which is a regular model. They will definitely frame a question related to filters. What data they will provide? They may give impulse response for us, or a transfer function, or a differential or difference equation. Once you convert into this form, h of s or h of z, it becomes easy for us to decide the nature of the filter. Then we have to deal with ROC of standard signals in jet plane. Like here we are dealing with sigma term. Here radius of the circle, absolute value, mod z. ROC of standard signals in jet plane is dealt with the mod z concept. Mod z, magnitude of the respective variable z. Okay. Here, one more question that is possible is eigenfunction. What is the concept of eigenfunction? Whenever the output answer contains input, it is treated as eigenfunction. Y of t equals to k into xt. If my input to the system is xt, again the output answer contains xt. If output contains the input form with some scaling factor, it is treated as eigenfunction. That is a regular model. Eigenfunction is also one regular question. Okay. Then we have to deal with convolution, time scaling property, time reversal, initial value, final value. Like the other chapters, here also we have to deal. But what is the difference in each chapter? When you are dealing with Laplace and jet transform, every property is linked with region of convergence. It's not that just we know the property, we got the answer. ROC. Time reversal property, ROC becomes 1 by R. Scaling property becomes mod alpha times R. That ROC based points we should observe very carefully. Okay. Then causality, stability in the jet plane. What is generally causality condition when we deal in the jet plane means outside the circle with the largest pole in magnitude. We have to take what? Outside the circle with the largest pole in magnitude. Stability means our shaded portion. ROC must include unit circle. Those type of points we have to observe carefully. So from this, in my observation, if you see the old GATE ESE papers, maximum number of questions from jet transform, they will frame from causality stability, maximum number of questions. Okay, this is a simple topic, relation structures. Direct form 1, direct form 2, that fellow will give some structure like block diagram, signal flow graph, which you are dealing in control subject. Here we have some structures, relation structures. They may miss any one coefficient, get me that value. They will provide the transfer function. In the middle, they will miss one of the coefficient, try to get that value. Very simple topic. That is also a possible thing. Relation structures. Okay. Okay. DFS and DFT, you should give more importance. Discrete Fourier series and discrete Fourier transform. Most of you are aware, definition of DFT is something like this. Sigma xn into wn power kn. We want to convert n number of points in one domain to n new number of points in another domain. With the discrete Fourier series, what is a small modification? Once you are available with x of k, we are representing discrete Fourier series coefficient symbol like ck. Extra it is multiplied by 1 by n. So if you know any one topic, automatically you will get the other topic with a minor modification, that is 1 by n. That is extra multiplier. Central ordinates. Central ordinates are linked to forward and inverse DFT. 50% of GATE questions are asked from that central ordinates. This is forward DFT, xk. When you deal with inverse, we are going to write the definition like 1 by n sigma 0 to n minus 1 xk wn power minus kn, wn power minus kn. So based on this forward DFT and inverse DFT, they may frame some models. One example to say, suppose I substituted k place 0, spectrum at 0, k place 0. This wn quantity becomes wn power 0. wn is the phase factor that is having standard form as e power minus j2 pi by n. If you know all that story, then you are easy to grasp what I am saying. Okay. So wn power 0 becomes e power 0, that is 1. Spectrum at 0 or spectrum at middle sample, capital N by 2. Similarly, inverse DFT, they may ask, get the answer at 0, small x 0 or small x of capital N by 2. That is called as central ordinates. So on central ordinates, they are framing a definite model. Then the other topic is how to do ordinary convolution using DFT. In ordinary convolution, you can have different length. But if you want to do that ordinary convolution by using DFT, the sequences must be provided with same length. For that, we are using a technique called as zero padding to take them as same length. So based on that, some models will be asked. Properties, few properties like time shifting, like I mentioned, central ordinates. And the main property of discrete Fourier series, especially for electrical engineers, every year they will concentrate is, if they frame a question on discrete Fourier series, definitely they will concentrate on this property, that is periodicity property of discrete Fourier series. Ck equals to Ck plus n. You see the last 3-4 years GATE paper, whatever the model that is given from discrete Fourier series, it is linked to that property. So signals is more of properties based. Signals is more of properties based. Okay. And till here it is, of course, you can feel like GATE syllabus. Some part of digital filters we have to study. That is for ESE exam, like IAR filter design, only basics, where we are learning some technique like IIT impulse invariant technique, bilinear transformation in IAR filter design. FIR filter design, how we are achieving linear phase, on what basis FIR filter can have linear phase, and a method called as window method. To design FIR filter, we need window method. So they will frame some questions related to this in ESE exam. So out of that 6 to 7 questions ECE fellows which we are getting in ESE, 3 to 4 questions are only from this topic or DFT, FFT. 3 to 4 questions are from filter design, or it may be from discrete Fourier transform, fast Fourier transform. Okay? So I have given a basic idea till now what models we have to concentrate related to the exams. It doesn't mean we have to study only these properties, we have to learn all the properties. More emphasis must be given on these properties, okay, related to different chapters. So just for your understanding, what I am going to do now is, few examples I selected which are maximum times repeated in exams. But don't concentrate only that examples, try to solve more models. Just for idea, the examples which were repeated regularly, based on that, some models I am concentrating, okay. Okay, be ready, think of and try to respond in the chat box. Very simple model. Find the value of the given integral. Integral contains an impulse known as sampling or shifting property. Integral xt into del of t minus t naught is what? X of t naught. Shift should lie within the limits. Then only there is a valid property. 0 elsewhere. If it is outside the limits, what is our answer? 0 elsewhere. Very simple bit. In the first bit, A bit, impulse exists at 1. Our limits of integration are minus 2 to infinity. Impulse includes, impulse is within the limits. So simply in the signal expression, substitute that instant. 1 plus cos pi. As the impulse exists at 1, directly substitute that instant. Okay? First, always you have to check if the integral includes impulse, it is immediate indication of applying our sampling or shifting, SIFT, shifting property of impulse. Let me see how many of you will respond for the second bit. Come on. Come on, come on. In the second bit, I have given for you the scaling property. It's not directly in normal form. So, del of alpha t 1 by mod alpha del of t. First, we have to convert that scaled form of impulse to normal form. So, if I am taking 2 common, it becomes 2 into t minus 2. 2 into, so further, minus 2 to infinity. Our original function as it is, del of 2t means 1 by mod alpha del of t minus 2. Impulse is within the limits or outside the limits? Impulse existed too after using that property, scaling property, within the limits. So in the function, what you have to do? Directly replace that instant. Directly, as the impulse existed at t equals to 2, substitute that instant, e power 0 is 1, result becomes 1 by 2. Result becomes 1 by 2. Just now I mentioned, based on the properties of impulse, you may get some examples. So this is one of the property of impulse. Okay. Okay, moving to the next one. Just to encourage you, few examples I am solving. Just to encourage you. Now you think of, explain the difference between each of the following operations. Another one I framed on impulse. First bit is linked to the product property of impulse. Xt into del of t minus t naught means x of t naught into del of t minus t naught, product property, first bit. So impulse exists at 1, directly in the signal, t place substitute. So E inverse into del of t minus 1. E inverse into del of t minus 1. So it is an impulse occurring at 1 with the weight of the impulse as E inverse, the weight of that impulse as. Second bit, like our previous slide, sampling property or shifting impulse existed 1 within the limits. Answer is simply replace that instant. Replace that instant, E inverse. First one is product property. Second bit is linked to sampling or shifting. Last one is convolution property of impulse. Xt convolute del of t minus t naught equals to x of t minus t naught. Any signal convolved by shifted impulse, respective signal is shifted by that much amount. So what we have to do? Directly in the function, in the original signal t is replaced as, t minus 1. So it's a decaying exponential starting from. Don't confuse between the three properties of impulse. Examiner wantedly he will confuse you. Product property means some fellows will write convolution property answer. So be careful. First one is product property. Second one is sampling or shifting, which we used just now in the previous slide. Sampling or shifting. Last one is the convolution property of impulse. Okay, let me go to the next model. As I said with you, energy, power signals, there will be a definite question. I want to ask you one model. Two sequences, discrete form, x1 of n and x2 of n have the same energy. Suppose x1 of n is alpha into something, where alpha is a positive real number. And another function x2n is having certain amplitude of root of 1.5 just for two samples. What is the value of alpha? What is energy in a discrete signal definition? Sigma mod xn whole square. Using this we have to solve. Sigma mod xn whole square. As the first function is multiplied by un, it is covering only positive index. It is multiplied by un. that is alpha square 0.5 whole square n. Sigma mod xn square is our relation, sigma. So further alpha square sigma 0 to infinity, I can adjust 0.5 whole square is 0.25, 1 by 4 for easiness. So it is sum of infinite terms 1 plus 1 by 4 plus 1 by 4 whole square series. So that can be written as what? First term by 1 minus common ratio. First term by 1 minus common ratio. We got energy in the first function, energy in the first signal. How to get energy in the second signal? It contains only 2 samples. How to get the energy in the second signal? It contains only 2 samples. Means, what is the range of this summation? It has only 2 samples. N varies from 0 to 1. So root of 1.5 whole square plus root of 1.5 whole square. That becomes 3. 1.5 plus 1.5. What is stated in the question? 2 sequences have the same energy. 2 sequences have the same energy. It means we have to equate the answer or not? We have to equate the answer. When you say EX1 equals to EX2, EX1 is 4 alpha square by 3, EX2 is 3. EX1 energy in the first function is 4 alpha square by 3, energy in the second function is 3, from which alpha square is 9 by 4, alpha is 3 by 2. Why I am not taking minus sign? Alpha is a positive real number. Alpha is a positive. So directly alpha becomes 3 by. So to answer this model, what is the first thought you need? To answer this particular example, what is the first thought you need? Energy in the discrete signal relation. If you know that relation, you can answer it. Okay? Okay, let me show you another example. Periodic functions, like I mentioned, they will ask for fundamental period or fundamental frequency. When multiple sinusoids are added, decide whether the signal is periodic or aperiodic. What is a simple direct logic without wasting our time? GCD of the given frequencies. Simply select GCD of the given frequencies. What are the frequencies available? Pi by 4, pi by 8, pi by. Try to get the GCD. 482 means what is the common multiplier? For 482, what is the common multiplier? 8. I can adjust the first one as 2 pi by 8. This is as it is. This pi by 2 can be adjusted as 4 pi by. So now you tell me what is the common frequency visible? Pi by 8. Pi by time period becomes 2 pi by omega naught. That is 16 samples. 2 pi by 8 means 16. Simply choose GCD, greatest common divisor of the given frequencies. Pi by 4 can be adjusted as 2 pi by 8. Pi by 8 as it is. Pi by 2 can be adjusted as 4 pi by 8. Very simple. This is a habituated model, regular model in the exam for all branches. Multiple signals are added means simply use the GCD logic. After getting omega naught, anyway we will get the time period 2 pi by omega naught. 2 pi by omega. Yeah. Then they may ask you questions related to the system's classification. Linearity of a system means what is the definite requirement? Sum of scaled functions should produce us. The response due to sum of scaled inputs must be equals to sum of scaled outputs. Obeying superposition. The output due to sum of scaled inputs must be equals to directly sum of scaled outputs. Similarly, they may concentrate on time invariance property. A shift in the input signal may cause shift in the output signal. Causality. How to deal with causality? The present output must depend on present input, past inputs, as well as past outputs. It should not ask for any future input. Y of n is the present instant. Present output should depend on present input, past inputs, x of n minus 1, x of n minus 2, past inputs, as well as past outputs. Static or memoryless system. Static system or memoryless. If the input and output are observed at the same instant, if I am checking output at 6, input must be also checked at 6. That is static system nature. If the input and output are observed at the same instant. Then stability. Stability is dealt with bounded input, bounded output, BIBO. Bounded input, bounded output. So these are the general system definitions. Examiner may ask for any 2 properties or certain times 3 properties. Okay? One example to tell you on this concept. I'll come back to that slide. Think of this. Different system expressions are given. In another list, system categories are given. We have to deal with the 3 properties there. Linear, non-linear, time invariant, time variant, static or time. When you see the first expression, all are linear elements. Of course, coefficients are independent of time, time invariant, but dynamic. n plus 1, n plus 2 is there means dynamic. Second expression, x square, squared is there. Non-linear, coefficient is external function of time index, time variant, memoryless. All are occurring at the same instant or not? yn, here xn, same instant. If you see the third one, linear, coefficient is external function of time index, time, variant, dynamic. Last one, unknown signal product, yn into yn type or y of n plus 1 into yn here. Non-linear, time invariant, dynamic. So you can answer this type of models once you are thorough with the definitions of the system. That is most important. Definitions, you must be thorough. Okay. So the second topic, just for idea I have provided this slide. Convolution means generally we are dealing with these different steps: folding, shifting, multiplication, integration. This is for continuous, this is for discrete, continuous case as well as discrete case. This is what I am saying. They will concentrate on properties. If the input and system both are scaled by alpha, same factor. Output also scaled by same factor with amplitude scaling of 1 by mod alpha. That is the scaling property of convolution. Area, AY is AX into AH. Area property AY is AX into AH. Differentiation. If the input and system differentiated m and n number of times, output is differentiated m plus n times. And the shifting property. When you want to delay the input by alpha, system by beta, overall shift is alpha plus beta. Of course, here only if I replace alpha as -1, that comes under x minus t convolved h minus t is y of minus t. Simply by replacing alpha as minus 1, that can be called as reversal property. Okay. All these properties were asked in the exam this year. They have framed a question for ECE based on the area property. Properties of convolution, you must be thorough. This is the favorite model for all competitive exam fellows, finite length signal convolution. Best and easy method is for sum by column method. When you have two finite set of data, how we are doing convolution? Normal polynomial multiplication style. Normal polynomial multiplication. Take the input and system, do that ordinary multiplication process. Sum by column method, simple method. So you can say that if the input has n1 samples and the system has n2 samples, here we have 3 samples, here we have 4 samples, 3 plus 4, 7, but output contains only 6 samples. Means the output length will be how much? n1 plus n2 minus 1 samples. If the input contains n1 number of samples, system contains n2 samples, the length of the output will be n1 plus n2 minus 1 samples. n1 plus n2 minus. Suppose in the same question, if this is unknown, assume h of n is known, y of n is known, x of n is unknown, the easy method is assume them as ABC, do that product, compare, then we are in a position to know ABC. This is a standard model. Multiple times this question is asked. This model, multiple times. Okay. How to answer this one? Given x equals to ABCD is the input of LTI system producing the output as repetition of the input n number of times. Output signal is periodic repetition of input means system must be a periodic impulse train. Output signal is periodic repetition of the input means system must be a periodic impulse train. Here it is mentioned that output is repetition of the input. It is go on repeating same data n number of times. First time it is due to only del n. Next time also it is due to del n causing 4 samples of shift. Same convolution property of impulse. X of n convolved del of n minus n naught means x of n minus. So first time it is due to only del n. Next time it has caused 4 samples of shift means delayed impulse. Next time it has caused 8 samples of. So this corresponds to impulse response. When you add all this, that will look like sigma del of n minus 4i. Sigma del of n minus 4i. Output signal is periodic repetition of the input means system is a periodic impulse train. System is a periodic impulse train. That is a simple thought you need. Okay. Then the properties of LTI system, where we are using the word only impulse response. What is causality, stability, memoryless, invertibility and inverse. Once the word impulse response is used, you are checking its internal behavior. General input output is external signal behavior. Once the word impulse response is used, it is internal behavior. So based on these stable characteristics, regular question will be there, regular model. So one example to tell you, if h of t is given as this function e power minus 3t u of t plus 4, respond whether it is causal or non-causal, stable or unstable. Think of e power minus 3t u of t plus 4 is given. So this function extends from, it is two-sided, before 0, after 0, means non-causal. What about the stability condition? Absolute area under impulse response must be finite. So minus 4 to infinity, e power minus 3 tau d tau, definitely it will be a finite number. After solving that integration, it will be mean stable. Based on the time constraint I am discussing, I am giving only idea for you. Okay? What are the possible models? Only idea. Such that when you observe that type of model, you will give more concentration. You should be thorough with the table. Thorough with the table. Okay. Recent times MSQs become so famous, so much famous. Multiple selective questions. This model touched for electrical. In the GATE exam, let us go one by one. Determine whether each of the following statement concerning LTI system is true or false. Justify your answer. What is the first one? If h of t is the impulse response of an LTI system and h of t is periodic and non-zero, non-zero means that periodic function has finite amplitude, then the system is unstable. It is 100% true, because assume I am taking a periodic function like this. Maybe it has finite amplitude for one cycle, which is of no use, because we are dealing with absolute area. It's not normal area, absolute area. Even h of t is maintaining finite amplitude level, it is of no use, as we are dealing with absolute area. 100% it is unstable. Periodic signals are everlasting signals. Once you take absolute area, it becomes infinity. B statement is, the inverse of a causal system is always causal. That is of course false. Why? Need not be causal. Why? Assume I have taken del of n minus 3. What is the inverse system I should choose to get del n? What is the inverse block I have to choose? I am available with Hn. What is the inverse block must be chosen to get del n? From the previous slide, what is our condition? Oh, just a minute. What is the condition? Hn convolved H inverse of n is del n. So he is saying original system is causal. Of course, impulse at 3 is causal. I have to take definitely here del of n plus 3. Then only I will get del, which is clearly non-causal. Impulse at minus 3 means, but what is the statement that is used? The inverse of causal system is always causal. Always causal is false. It may be causal. Maybe chance is there, always causal false. Third bit, if a discrete time LTI system has impulse response, study it properly. a finite duration of finite amplitude. It has length finite, amplitude also finite, then the system is stable. Indirectly, it is an FIR filter. FIR filter with finite amplitude, of course, that statement is true. We have finite number of samples with amplitude finite. One example to tell you for CBIT. If I have taken 3 samples like this, what is stability condition? Sigma 0 to 2 mod Hn. I have chosen only 3 samples. All are having amplitude of 1. Once they are added, automatically answer is finite, means stable. Correct or not? Finite duration of finite amplitude. If this word finite amplitude is not given, it may be wrong. Because if I take a sequence like 1 by n for 0 to 2, 1 by 0 becomes infinity. So finite duration of finite amplitude. Generally, FIR filters are guaranteed to be stable because they will maintain finite amplitude. That is true. Last statement. If an LTI system is causal, it is stable. What you can say? If an LTI system is causal, then it is stable. What you can say? No. False. Why? Causality will never guarantee stability. Let us assume e power 2t ut, which is a growing exponential. It is a growing exponential that is defined for positive time. But once you check the stability, integral mod h tau d tau is our condition. Integral mod h tau d tau. It is a growing exponential, so integral 0 to infinity e power 2 tau. Of course, unbounded function. It is unbounded function or not? Causality never guarantees stability. One example is like this. It is unbounded function. As it is defined for positive time, it is causal, but stability is not guaranteed. Okay? Like that, some standard examples of each topic I am going to discuss. Next, we have one more session after 2 days. In that session, I will continue our discussion. So today, basically, I want to give an idea which models you have to concentrate. Some more models after 1 or 2 days. The session will be there. In that, we are going to discuss. Thank you.